Welcome. Let's look at an introduction to functions of several variables. Let's start by looking at a function of two variables. So a function of two variables, z equals f of x and y, maps an ordered pair x and y in a subset of the coordinate plane R2, sometimes we refer to that as the xy plane, to a unique real number z. This set D is the domain of the function x and y. The range of f is the set of real number outputs z produced by the ordered pairs in set D. So in this image here, we have a set that represents the domain of a particular function. If we take an ordered pair from that domain and we evaluate that ordered pair in a function f, it will produce an output, a real number z, somewhere within the range of that function. So to summarize, we say that the domain is the set of all possible values of x and y, or set of all possible inputs to the function. The range is the set of all possible outputs, or z values, where the input values come from the domain. And the graph of the function is the set of all points x, y, and z produced by the function. And the graph of a function z equals a function of x and y is in fact a surface. So let's go ahead and find the domain and range of this particular function. The first thing I notice about this function is that it is linear. Linear functions are functions where the degree of the variable terms is 1. And so I can see the degree of the x variable term is 1, and the degree of the y variable term is 1 as well. Now remember that the outputs of this function are our z values. So we can think of this as being also an equation like z equals 5x minus 3y plus 2. And we should recognize this as being a plane in space. Now we should notice that for this particular function, there are no values of x or y that would cause the function to be undefined. So the domain of this function is all real numbers for x and y, which basically creates the xy plane, or R2. That's the domain. Now we need to think about the range of the function. So we have this equation that relates the function to z, and we need to explore the relationship between the variables x, y, and z. Now, one way of doing that is to choose a value for x or for y and see what happens to the remainder of the equation. So let's go ahead and we'll let y equal 0. And so what that means is that now our equation is 5x minus 0 plus 2 equals z. And let's go ahead and solve for x. So we have 5x equals z minus 2. And we'll go ahead and divide by 5. So x equals z minus 2 over 5. Now remember, the domain of the function is all real numbers. And what we've just done is we've created an ordered pair in the xy plane where the x coordinate is z minus 2 over 5 and the y coordinate is 0. And notice that there's no restrictions here for z. Z can be any real number, and we would have an ordered pair that would lie within the domain of our function. Since z can be any real number, so z can be any real number, that is the range of our function. Now let's look at a second example. Notice that for this function that we want to find the domain and range for, we're taking the square root of 4 minus x squared minus y squared. So let's go ahead and first think about the domain. Since this expression 4 minus x squared minus y squared is underneath a radical, underneath the square root, when we're thinking about the domain, we have to be sure that that expression is positive, or it could be 0. So 4 minus x squared minus y squared must be greater than or equal to 0. Now, you may not recognize what this looks like in the xy plane in this form. So let's go ahead and add x squared and y squared to the right hand side of the inequality. So we end up with 4 is greater than or equal to x squared plus y squared. Now, if we think about the xy plane, and we focus for a moment on the equal to part, on the x squared plus y squared equals 4, then we should recognize that that's a circle centered at the origin of radius 2. So if I scale my axes to indicate increments of 2, then that circle would look something like this. And this would be a solid circle as I'm considering my domain, because I see this equal to in the inequality. Now, the question is, how do we deal with this 4 is greater than x squared plus y squared? Well, that circle divides the plane into two parts, the inside of the circle and the outside of the circle. So we test points to see whether the inside of the circle satisfies the inequality or the outside of the circle satisfies the inequality. So let's start with something easy on the inside, like maybe the origin. So the question is, if I substitute 0 for x and 0 for y, do I have a true statement? Is 4 greater than or equal to 0 squared plus 0 squared? And yes, that's true. 4 is greater. So we're pretty darn sure that the domain is the interior of the circle. But just to be certain, let's pick a point on the outside of the circle. And let's pick a point like up here. Let's pick 0, 3. That's a fairly easy point to work with. And so the question is 4 greater than or equal to, let's see, my x is 0, so 0 squared plus 3 squared. That's a question. Is 4 greater than or equal to 9? And no, that's not true. So now we know that the domain is the boundary, that circle, and its interior. So we can write that the domain is the set of all points xy such that 4 is greater than or equal to xy. And here is a graph of that domain. Now we were also asked to find the range of the function. And so now we have to consider what happens to these output values. Now if we think about this expression underneath the radical, if we were to graph that expression, if we were to graph z equals just the function underneath the radical, so 4 minus x squared minus y squared, that would be a paraboloid opening down because of these negative coefficients, with the vertex being at 4. So the maximum value of that paraboloid occurs at 4. And if the maximum value for this expression underneath the radical is 4, then the maximum value of z, or the maximum value for the output, would be the square root of 4. So my z value could not be any bigger than the square root of 4. Now, we're taking the square root of an expression, and so when we evaluate this expression, we know that the smallest this can be, the smallest this expression can be, is 0. Because if it's any smaller than 0, we're dealing with complex numbers, and those values of x and y are not part of our domain. So the smallest value this expression could take on is 0. So z must be greater than or equal to the square root of 0. Well, the square root of 0 is 0. Less than or equal to, and the square root of 4 is 2. So the range of this function is between 0 and 2. I hope you find this helpful.